let's talk about the one thing every engineer deals with. It's this constant, brutal battle, right? On one side, you've got this relentless pressure to cut costs. On the other, the absolute non-negotiable demand for quality. And if you get that balance wrong, well, you're not just looking at a failed project. You could be looking at a catastrophic failure. So that really brings us to the million-dollar question, doesn't it? How do you actually cut costs without cutting corners? I mean, how do you find those massive savings while making sure integrity, safety, and function are completely locked in? Let's dive in and figure it out. Okay, here's how we're going to break it down. First, we'll look at that constant cost pressure. Then, we'll shift gears to something called the value engineering mindset. After that, we'll open up a toolbox full of strategies you can actually use. Check out the numbers to prove it works, and wrap it all up with one final powerful equation. All right, first up, the constant cost pressure. Let's just take a second to really understand the world we're operating in. It is, without a doubt, a high-stakes game. Every single dollar counts, and that pressure to cut costs, it's coming at you from every single direction. And you don't have to take my word for it. Check out this quote from an engineer, someone right there on the front lines. They say, "Management pushes engineers a lot to reduce costs. Most of the cases, this leads to choose poor material and bad suppliers." I mean, that just captures the danger perfectly, right? When the push is just cost at all costs, you end up making choices that, yeah, they look great on a spreadsheet, but they lead to shoddy materials, unreliable suppliers, and, you guessed it, product failure. And look, here's the cold, hard business reality. Your product can be a total engineering marvel, a work of art, but if you can't build it profitably, it's a failure. Simple as that. That's why managing cost isn't just something for the finance guys to worry about. No, it's a core discipline for every single engineer out there. Okay, so if just slashing costs blindly is the problem, what's the solution? Well, it's not about working harder, it's about thinking smarter. It requires a really fundamental shift in how you look at the problem, and that's where this powerful methodology called value engineering comes in. So what is value engineering? You might hear it called VE or VAVE, but here's the key thing to remember. It is not about making things cheaper. Not at all. It's a systematic way to analyze every single component, every single process to figure out how to get its essential function done at the lowest possible life cycle cost. And this part is absolutely crucial. The basic functions must be preserved. You're not compromising, you're optimizing. Big difference. And at the very heart of this whole philosophy is a beautifully simple formula. Ready? Value equals function divided by cost. Think about that for a second. It means you've got two levers to pull to increase value. You can either boost the function for the same cost, or you can keep the function exactly the same but for a lower cost. It's just a really elegant way to completely reframe the entire challenge we've been talking about. And just to show you this isn't some vague, fuzzy concept, take a look at this. Value engineering is a structured, repeatable process. It's a system. You start by gathering all your info. Then you move into analysis, and this is where you ask the really important question. What does this part actually do? What is its core function? From there, you get creative, you brainstorm new ideas, you evaluate them, and then you implement the best one. It's basically engineering applied to the cost itself. Pretty cool, right? Okay, so that's the big idea, the philosophy. Now let's get our hands dirty. We're moving from theory to a practical toolbox. We're talking actionable strategies that you can literally start using on your very next project. All right, this table right here lays out some absolute heavy hitters. I mean, just look at the potential savings. Leveraging automation, that can slash your design time and cost by 30% or even more. Or how about this? Employing simulation to cut down on physical prototypes, you could save up to 50% on testing. We are not talking about minor tweaks here, people. These are total game changers. And you've got to know, these savings really come in two flavors. You've got your direct savings, which are the obvious ones, right? Lower prices for components, cheaper manufacturing, easy to see. But then you have the indirect savings. And honestly, this is often where the real magic happens. We're talking less time sunk into research, fewer painful redesigns, and a way faster turnaround time. Remember, time is money, and these indirect savings, they add up fast. Now, let's get some pro tips from the trenches, from engineers who've been there, done that. First off, and this is a big one, go talk to the people on the assembly floor. Seriously, they know where the real-world problems are. Next, commonize your hardware. Even if a part is a little over-spec'd, reducing the number of different parts you use simplifies everything, from inventory to the actual assembly. And finally, always be on the lookout for ways to reduce manufacturing operations or widen your tolerances where you can. Every single step you can eliminate is a cost you save forever. So we've got the philosophy, we've got the tools, but the big question remains, does this stuff actually work in the real world? Well, the numbers don't lie. Let's take a look. 22%. Let that sink in. What is that number? That's the average cost reduction on huge construction projects that made the switch to modular techniques. I mean, that is a perfect real-world example of value engineering in action. But wait, it gets better. It's not just about the money. 35%. That's the average reduction in the project timeline from that same study. So think about what that means. You're not just saving cash, you're getting your product to market more than a third faster. That is a massive competitive advantage. And these charts right here, they just lay it all out so clearly. It's beautiful. On the left, you've got your cost per square foot. On the right, the project timeline. Just look at those orange bars. In every single category, residential, commercial, industrial, the modular approach is consistently cheaper and faster than the old school way. I mean, the evidence is just crystal clear.
Okay, let's make this even more real. Here's a specific case study. A team took an existing industrial component and applied the VAVE process to it. And the result? Get this, a stunning 38% reduction in direct material costs. But they didn't stop there. They simplified the design so much that they cut the total number of parts by 34%. Think about that. It's cheaper to make, it's faster to assemble, and it's way, way simpler to manage. That's a huge win.
Okay, this brings us to our final point. And honestly, this is the most important takeaway of all. It's all about reframing the very goal of what we do as engineers. So I want to leave you with this one simple question to think about. Is your goal on the next project to simply reduce cost, or is it to maximize value? Because when you start focusing on that amazing ratio of function to cost, something incredible happens. You're not just cutting expenses anymore. You're forced to innovate. You have to dig deeper and find smarter, more efficient, more elegant solutions. And that is the final equation. That's how you turn all that pressure to cut costs into a powerful catalyst for truly great engineering.